Outcome 2A, irrational numbers in radical form. Outcome 2A, students will demonstrate understanding of irrational numbers by determining if a number is an irrational number, ordering rational numbers, and knowing where they may be used. Lesson 1, Irrational Numbers. The decimal form of an irrational number can either the decimal form of a rational number can either terminate or repeat. So rational numbers will be things like 2.5, 3.666, repeating. They can also be whole numbers, such as 5. The decimal part terminates or repeats. Radicals that are the square roots of perfect squares, cube roots of perfect cubes, and so on are also rational numbers. Rational numbers have a decimal representation that terminate or repeat. Irrational numbers cannot be written in the form m over n, where m and n are integers. The decimal representation of an irrational number neither terminates or repeats. So it's going to continue forever with no repetition. The rational numbers include natural numbers, whole numbers, and integers. These numbers are the irrational form. These numbers and the irrational numbers form a set called real numbers. So if we look at the square, the whole group of all the numbers that we know are called real numbers. Within there, they're separated into two groups represented by the two large rectangles. One are rational numbers and one are irrational numbers. Within the purple rational number square, we then have sets of numbers such as integers, natural numbers, and whole numbers. When an irrational number is written as a radical, the radical is the exact value of the irrational number. For example, the square root of 2 and the cube root of -50. We can use the square root and cube root keys on a calculator to determine the approximate values of these irrational numbers. If we do the square root of 2, you're going to get something like 1.414213562. The numbers appear to stop on your calculator, but only because your calculator runs out of space, not because those numbers actually stop. The term rational was created to denote numbers that can be expressed as a ratio. The prefix irrational denotes not, as in irregular. Therefore, irrational numbers are not rational. Tell whether each number is rational or irrational and explain how you know. Well, the first one I know is rational because it can be expressed as a fraction. The second one, if we look at the square root of 14 and punch it into our calculator or change it to a decimal, we have 3.74165, and that decimal continues. Because it continues and there's no repetition, it is an irrational number. The cube root of 8/27, if I punch it into my calculator, will give me 2/3 as a fraction, or your calculator may give it to you as a decimal of 0.6 repeating. Because it repeats, it is a rational number. Use a number line to order these numbers from least to greatest. I think the easiest way to order irrational numbers is to change them into their decimal forms or their approximate decimal forms, and then order those ones. So if we start with the cube root of 13, the cube root of 13 is approximately 2.35. The square root of 18 is 4.24. The square root of 9 is going to be 3. The fourth root of 27 is 2.28. And the cube root of -5 is -1.71. So if we look at the smallest number in that group is 1.71, which started off as the cube root of -5. The next largest number will be 2.28, which was the fourth root of 27. Then we have 2.35, which was the cube root of 13. 3, which was started as the square root of 9, and 4.24, which started as the square root of 18. We can also place those numbers on a number line, so they have to range between -2 and +4. So we'll do -2 here, and I'm going to leave some space, so make this -1, 0, 1, 2, 3, and 4. If I'm starting with my smallest number was -1.71, so not quite -2, so this will be my first one, will be about here, and that was the cube root of -5. The next one, the fourth root of 27, is positive 2.28, so somewhere in here, and it started as the fourth root of 27. I then have 2.35, which is also right in there, and that started as the cube root of 13. I have 3, which was the square root of 9, and 4.24, which started as the square root of 18. Okay, time to try practice number 1.